In this lesson, we're going to discuss functions, arguments, and data types in JS. We'll begin with a revision of functions and what you've learned so far. In the code on the left, what is the function declaration? What is the function execution? Where are the parameters? Where are the arguments? And what if we use numbers instead of the strings of blue bottle and gray cap when we executed the function? This is what I'll discuss in this video. First, let's answer the question of what data types can we use when invoking, calling, or running a function. There's nothing preventing us from passing various values or various data types to the bottle capper function. It's all about how a function is defined. The bottle capper function is defined in such a way that allows us to pass any value of any data type to the function invocation, and JavaScript will do whatever it can to comply to our command. This might result in some weird output. Up until this point, I've shown you the following data types. Some primitive data types, namely string, number, boolean, and undefined, and some complex data types, namely objects and functions. We won't discuss the significance of the function data type at this point. I'll leave that for later for the sake of clarity of what I'm showing you right here. So, what I'll do next in this video is I'll show you how to invoke the bottle capper function and pass all these various values as arguments. That is, as the raw materials that our bottle capper machine will use to produce some output. Okay, so now I'll go into the browser console and show you some examples of how this works. Here I have typed up several lines of JavaScript code in the browser console. I haven't yet executed this code. At the very top, I have the bottle capper function declaration that I've discussed in the previous video, so nothing new there. Now, let me highlight this bottle capper function invocation. I'm invoking it using the name of the function, that is bottle capper, and then I'm passing it two strings inside a pair of parentheses. The strings that I'm invoking my function with are green bottle and white cap, with a space character being the first character of the second argument. I've previously shown you how this works, and the expected output of this is going to be a single concatenated string of these two string values. I'm assigning the result of this function invocation to the variable named str. But what if I invoke the bottle capper function with various other values, even combinations of different data types? On the next several lines, I'm saving the result of invoking the bottle capper function with a string and a number, then a number and a string, then undefined and a string, and finally two empty objects. To reiterate, I'm assigning the value of invoking a function to a variable declaration. Does this code look familiar? Actually, it's very similar to the code I used when I was getting some user input using the prompt. Well, now that you've learned how functions work, I can let you in on a little secret. The prompt is actually a function. It not only is a function, but it's also a built-in function, meaning it comes pre-installed with JavaScript itself. In other words, the prompt function is already defined by some browser vendor, or that is, the people who have coded the browser and the JS engine. So, just for the fun of it, let me also invoke the prompt function again. This time I'll ask the question of, did you know what prompt is? And I'll save the answer to the variable named prompt is a function. Okay, so now when I execute all this code, what do you think will happen? Well, JavaScript will read this code from top to bottom, and it will save all these invocations of the bottle capper function to these 6 variables right here. And then it will execute the prompt function and wait for my input before it saves its result into the prompt is a function variable. So let's now run this code. The prompt pops up almost immediately. That's because computers are quite fast and the JS engine has already saved all the returned values of these 6 invocations of the bottle capper function into these 6 variables right here. Finally, it reaches the prompt and pauses further execution, waiting for me to type into the input. So I type my answer. Yes, prompt is a function. And now the JS engine returns the value of undefined. That's because the prompt function was the last one invoked, and it's defined without a return value. Thus, the default function behavior kicks in and returns the value of undefined right here. Now I have all these variables saved in a world that I've told JavaScript to build, which means that I can now inspect the values of all these variables. I'll utilize the evaluation hints that I've discussed in the previous videos. So, instead of typing the actual variable and pressing the Enter key, it's enough for me to just type a variable name, and the JavaScript engine will show a preview of what's that given variable going to evaluate to. Let me show you the contents of each of the variables that I've previously declared. First, the str variable. It returns the result of concatenating 2 strings, namely the string of green bottle, white cap. Next, the strnum variable. It is the result of the bottle capper function, accepting a string argument and a number argument, and it returns a string argument. How did that happen? Well, when you use the plus operator with one value being the number data type and the other value being the string data type, JavaScript coerces the number value to its string counterpart. This word, coerce, is used to describe the process of JavaScript making a decision of how to convert a specific value when that value is used with a specific operator and another value of a different data type. In this case, JavaScript had to decide if it was going to treat the string as a number or the number as a string. Generally, converting a string to a number is more ridiculous than converting the number to a string, so JS coerces the second argument, which is the value of 2 of the number data type, to a string. Thus, the strnum variable's value is green bottle 2, without a space between the word bottle and the number 2, and also the entire value coerced to the string data type. By a similar process, the value of num str variable was set to the string of 2 white cap. And here there is a space between the number 2 and the word cap in the resulting string, because the space character was already there in the second argument. Next, when I pass the value of undefined as the first argument and the string as the second argument, I got back a string. In this case, it was undefined white cap. Finally, the output of invoking the bottle capper function with 2 empty objects as its arguments returns this weird string. The string contains the word object with a lowercase o, then the word object with an uppercase O, both surrounded in an opening and a closing square bracket. And this weird looking thing is repeated twice. Alright, so that's it for this video. This is probably the most difficult lesson of the entire bootcamp up to now. In the next video, I'll be discussing a topic that should be a lot easier to understand, namely the topic of function generalization.